Assalamualaikum warahmatullahi wabarakatuh. In this video, we are group 2. We'll explain about shape and dimension. So our is me as the moderator and the first speaker, Tika Syahada. And then the second speaker, Yelli Wijayanti. And the third speaker, Tika Aprilia Puspita. Next. Okay, from unit 1, we have the material about lines and angles. Next. Okay, before we jump to the types of lines, I will introduce you what are lines itself. A line is a straight one-dimensional figure that extends in the opposite directions infinitely. A line can be horizontal or vertical, and it can be drawn from left to right or top to bottom. And there are two major types of lines, the basic one and lines that based on concepts. For the lines are basically categorized as line segment and ray. And then for the based on concepts or operations performed on line parallel lines, perpendicular lines, and transversal lines. Next. Okay, for the first lines, we go to the line segment. So that are the figure of line segment. Line segment is a part of a line with two endpoints. It is the shortest distance between 2 points and has a fixed length. So the line segment has two endpoints. And the second one, ray, is a part of a line which has a starting point and extends infinitely in one direction. Next. Okay. For parallel lines, two lines are said to be parallel when they do not meet at any point in a plane or which do not intersect each other. And in the figure, you can see lines P, Q, and RS are parallel to each other. Okay, and for transversal line, you can see the figure. When a line intersects two lines at distinct points, it's called transversal. Okay, and in the figure, as you can see, a transversal intersecting two lines at point P and Q. Sorry, I mean key. And then for perpendicular lines, we set the lines as perpendicular lines when two lines form a right angle with each other by meeting at a single point are called perpendicular lines. And in the figure, as you can see on the screen, you can see lines AB and CD are perpendicular to each other. Next. Okay, we come to the next types of unit 1 is types of angles. I will introduce you what are angles itself. Angles are the shape that is formed when the endpoints of two rays meet at a single point, and they are measured in degrees or radians. And a complete rotation is equal to an angle of 360 degrees, and it's represented by the symbol core. And there are two types of angles. The first one, angles are basically classified as acute angle, less than 90 degrees, right angle, equal 90 degrees, obtuse angle, more or greater than 90 degrees, and straight angle equal 180 degrees. And based on the relation between two angles, conceptual wise, there are supplementary angles, complementary angles, adjacent angles, and vertically opposite angles. Next. Okay, the first one is acute angles. You can see the figure of the screen. If the inclination between the arms is less than a right angle, so we call an acute angle. Okay, because the core of that figure is less than 90 degrees. And for obtuse angle, if the inclination between the arms is more than a right angle, it's called an obtuse angle. And the next one. Okay, right angle. If the arms form an angle of 90 degrees between them, it's called right angle. And the next one, straight angle. We call that figures as a straight angle when if the arms form an angle of 180 degrees between them. Next. Okay, we come to supplementary angles. Take a look on the figures. Two angles which sum up to 180 degrees are called supplementary angles. So there are the side one is 120 degrees and the other side is 60 degrees. And for complementary angles, two angles which sum up to 90 degrees are called complementary angles. The first side is 30 degrees and the other side is 60 degrees. Next. Okay, adjacent angles. So adjacent angles means that two angles which have a common side and a common vertex are called adjacent angles. In the following figures, we can see A core and B core are adjacent angles. Okay, and for vertically opposite angles, it means that two angles which are formed opposite to each other when two lines intersect at a common point or vertex, and we call vertically opposite angles. So in the figure given below, we can see core POR equal core SOT and core POS equal core ROT. Okay. All right, that's all for the explanation from Unit 1. Next, we come to Unit 2, two-dimensional shapes that will be presented by our second speaker, Yelli Wijayanti. For Yelli, time is yours.
All right, thank you, moderator. Here I will explain about two-dimensional shapes. The first one is triangles. There are three triangles here. The first one is acute angle triangle. All the sides of the triangle have the same length and angles are the same size. Like this one, 60, all the same size. And also, the second one is isosceles triangles. The two sides and two angles of the triangles are the same. The next one is scalene triangle. Here means scalene triangle. Here means all sides and angles are different from each other. Next. And here are the Theorema Pythagoras to measure the three angles. C square equal A square plus B square for measure Theorema Pythagoras. Next. Next one is circles. The first one is circles, means full circles. And then the second one is semicircles, means a half of circles. And then radius means a straight line from the center to the circumference of a circle. And the next one is diameter. It means a straight line passing from side to side through the center of a body or figure, especially circle. Next. Here are the circles. The second one, segment. Here the yellow one is the segment of a circles. And then the third sector, the pink color is a sector of a circle. And then here are the tangent. Here are the pictures of tangent. And then second, here the line here means of a second of a circle. And the last one is a circumcircle. Next. This is another angles. Another circle have three angles in it, means subtended angle. And the last one is concentric angle. Next. And more two-dimensional figures. The first one is square. Square is a two-dimensional shape with four equal sides and four vertices, like this one. All have the same length. And then the second one is rectangle. A rectangle is similar to a square, but the vertical and horizontal sides have different length. Like as you can see in the picture. And the third one is rhombus. The fourth one is rhomboid. And both of them are almost similar. Next. Here are another two-dimensional figures. The first one, quadrangle. As you can see, all the sides are not similar. And then the next one is pentagon, trapezium, hexagon, ellipse, and spiral. I think that's all from the two-dimensional shapes from me. Thank you. Back to moderator.
All right, thank you, Yelli Wijayanti, for a nice explanation. Next, we come to Unit 3, three-dimensional figures, and also 4. And that those two units will be presented or explained by Tika Aprilia, our third speaker. For Tika, time is yours.
All right, thank you, moderator. So in this section, I will explain about three-dimensional figures. So we have identified two-dimensional figures before, and now we will identify three-dimensional figures. So three-dimensional figures known as solids and have three different measures, such as length, width, and height, and as its dimensions. And the only difference between two-dimensional figures and three-dimensional figures is that three-dimensional figures have a thickness or depth, while two-dimensional figures do not have a thickness or depth. All right. Okay. So here, types of three-dimensional figures. The first one is cube. A cube is a solid or three-dimensional shape that has six square faces. All the faces of the cube have equal shape. We can find example of cubes on Rubik and dice that consists of 1 to 6 points. The second one is rectangular prism. A rectangular prism is also known as cuboid. The faces of the cuboid are rectangular. All the angle measures are 60 degrees, just like a cube. And we can see the example of this shape in a matchbox, book, or a cupboard. The next one is cone. A cone is a solid object that has circular base and a single vertex. It's a geometrical shape that tapers smoothly from the circular flat base to a point called the apex. At the apex, we can see an example of this shape in a birthday hat or ice cream cone. The next one is triangular pyramid. A triangular pyramid is a shape that has triangular base and three triangular faces. It has a vertex common to all three lateral faces of a triangular pyramid. The next one is square pyramid. Square pyramid is a pyramid that has 5 faces, including 4 triangles and 1 square as the base. So we can see the example of this form in the pyramid in Egypt. The next one is triangular prism. A triangular prism is a shape made up of 2 triangular bases and 3 rectangular sides. It's a three-dimensional shape that has 3 side faces and two base faces connected to each other through the edges. So we can see the example of this form in the yacht scout tent. The next one is cylinder. A cylinder is a three-dimensional shape consisting of 2 parallel circular bases joined by a curved surface in the form of rectangle. We can see the example of this shape in bottles or lipstick. And the next one is sphere. A sphere is a three-dimensional solid figure which is perfectly round in shape, and every point on its surface is equidistant from the point called the center. We can see example of this shape in balls, such as footballs or baseball. The next one is a length, width, height, and depth. So length is distance from one end to another, the orange one here. The width is the distance from one side to another, and the blue one, the height. The next one is height. The height is distance from the bottom to the top, and the depth is how far something goes into space. So here the volume, the formula for the volume and surface area from this shape. The next one is diameter, bore, and thickness. The bore diameter is the inner diameter or inside diameter, the blue one in the picture, while the thickness refers to the wall of the cylinder or wall thickness or wall thickness in the picture, the green one. These images also include three-dimensional shapes, and we can see the example of this form in toilet paper or pipes. All right, the next one is graphs and values. All right, so the first one is sample graph. The figure beside which contains a number of blocks is called a block diagram, a bar graph, or a histogram. We can see that it contains blocks of different size. These blocks might represent quantities of something, for example, the number of rainfall, the level of mortality rates, and etc. In this picture, it represents grafik penjualan spare part kendaraan bermotor. The next one is a pie diagram. The figure beside is an example of circular graph, which is also called pie diagram. A graph might also be circular. Oh, sorry. The figure beside is an example of a circular graph, which is also called a pie diagram because of its shape. Notice how the circle is divided into sectors, each representing a certain quantity. This pie diagram, besides represent the percentage of people's hobbies or skill, like football, cricket, badminton, hockey, and other. The next one is still simple graph. Unlike the two kinds of diagrams mentioned before, actually what is meant by graph is in mathematics is a line which is plotted on two axes, that is the x-axis and the y-axis. They as you can see in the first picture, and they intersect at a point which is called the origin of the graph, and you can see the second picture. And the next one is curve graph. In the figure 1, show the graph of the so-called normal destiny function. Figure 2 presents two normal distribution with the same value, and the figure 3 present a comparison of two normal distribution with the same value. And the question here is why values appear in a curve form instead of straight line when presented in a graph. So if all equation has a power of values greater than one, the graph will be curved. So it implies that when value resulted in by the equation are presented in the graph, they will show quantities that do not vary in direct proportion. Therefore, they yield a form of curved graph. The next one is this picture. In this figure, the axes have been extended and the origin is now in the center and not in the bottom left-hand corner of the graph. The axis divided the plane into four quadrants. You can see the origin O and the four given quadrants in the figure. The two quadrants on the right side of axis Y have positive value of X. For example, +1, +2, +3, and so on. And while the other two, one the left have negative values, for the example, -1, -2, -3, and so on. And the two quadrants above axis X have positive values of Y, whereas the other two quadrants, which are below axis X, have negative values. All right, I think that's all from me. Back to moderator.
Okay, thank you, Tika Aprilia Puspita, as our last speaker. And it means that the end of our presentation about shapes. And thank you for your attention. I am moderator Tika Syahada. Assalamualaikum warahmatullahi wabarakatuh.